Hi everyone, and welcome to my presentation. I'm Gaten, security researcher here at Git Guardian, where my job is to find and analyze secrets, breaches, incidents, and all kind of things. Today, I want to talk about secret leaks, and especially about how attackers and threat actors can take advantage of them during their attacks. So let's get started. To illustrate those leaked secret based attacks, I want to use my favorite secret types out there, both as a security researcher and red teamer, namely Artifactory API keys. If you don't know Artifactory, so it's a software repository manager software developed by JFrog, which basically stores software packages inside repositories. Uh, a repository can be seen as a specialized directory which contains software packages and artifacts. There can be repositories for PyPy, for example, for Python projects, or for Docker, similarly to how Docker Hub works, or NPM, or more or less anything you can think about. And it has a lot of enterprise-grade features, which makes it one of the favorite repository manager software for enterprises. It's often seen as a critical component, and for good reason, which makes it a very nice target for attackers. And every year we hear about new vulnerabilities targeting Artifactory, either found by researchers or exploited in the wild. But today, we don't want to focus on those software vulnerabilities, but on how you can exploit an Artifactory once you have a leaked key. Uh, there are a lot of alternatives to Artifactory, like Nexus for the open source uh, software. You also have Arbor for Docker, GitLab, and basically a lot more. Um, all points described in this presentation are also valid for those alternatives. Um, they basically all work the same and follow the same architecture. I said Artifactory is seen as a critical component. The main reason why it is that it is linked to a lot of systems and parties with which it's interconnected. The main example of those interconnection is with CI/CD pipelines for integration and deployment, um, where the CI/CD pipeline will um, connect to Artifactory to retrieve software components to be able to build softwares, and will also push the result of those builds once it's done. So to store the resulting package long term. That's one connection, but Artifactory is also connected to developers who need to pool dependencies to be able to build their projects locally and run tests, for example, and to production servers, because at some point your production artifacts will have to be deployed to the production environment to be able to be made available where it is supposed to be. Uh, the last connection, which is somehow indirect, is with third party, which might have to pull packages from your Artifactory to build their own software if, for example, you expose dependencies to customers or if you are writing open source software components. Of course, all those interactions are made with authentication, and so every party will have to own its own API key. For example, for the CI/CD pipeline, this component will have to own a key that will allow it to pull and push packages from the repository. Because Artifactory relies on API keys for authentication, and because we know that API keys leak, and if you haven't read the last State of Secrets report from Git Guardian, you should have a look at it. We observe millions of leaks every year, and Artifactory is no exception. We find Artifactory keys in the wild, and also because Artifactory is interconnected with a lot of parties, a lot of keys will live around it. And of course, Artifactory being closer to production, production servers will use software packages, and production CI/CD pipelines will use also software packages from the repositories. The chances that a leak occur increases, and in fact increases quite a lot. So we observe leak in real life, leaks of Artifactory API keys. And the main place where we find leaked keys is in configuration files, either build configuration files, project configuration files, and that makes sense considering Artifactory is mainly used during the build of packages. We find keys in build configuration files. Here, for example, on the left, you can see a developer who leaked an Artifactory API key in a Gradle configuration file, which defines a way to pull dependencies from the Artifactory server. And on the right, on the contrary, we have a Jenkins file, which is used to push the results of a build. So here, a jar archive, and which also contains an hard-coded Artifactory key. So this was the main places where we find keys, but we also find keys in source code, mainly in two types of sources. The first one is developers who hard-code their keys in what we call .files repositories, which are basically repositories containing scripts and configurations that help set up a development environment. So we observe a lot of people storing their .files on public GitHub repositories to be able to quickly start a new environment if needed. And here, for example, on the left, you can see a very short shell script containing definition of environment variable, which contain some secrets. The second case is DevOps scripts, which might have to interact with an Artifactory server for some reason. And here, for example, we have a small Python script, which also contains an hard-coded Artifactory key. What is very interesting with the first example here, so the .file repository, is that very often those .files are stored in personal repositories. They are, in most cases, located completely outside of the company perimeter. And for this reason, they can be pretty hard to detect if you only monitor your company's repositories. So now that we know that leaks happen and that Artifactory API keys happen, we can ask ourselves, okay, what's the real impact? What are the consequences? And to illustrate this, I want to show you a little case study with a developer working on a small Python project. that's what we see here, a very classical development environment with a developer working on a Python project. And it happens this developer forgot to push the build configuration file to the repository. So he will now add this configuration file to the repository and push it on the remote GitHub public repository. So until here, everything seems perfectly fine. But now, if the developer wants to update its project dependencies, we'll observe something unexpected. There is a dependency that changed version from 0.1.2 to 0.1.3, and now when my developer tries to execute its application, we can see that something unexpected happened, and okay, some code is executed that was unexpected. So there was an attack here. Let's dive into the details to understand what happened. So first, the project build configuration file contained a section to be able to retrieve dependencies from an Artifactory server. Unfortunately, the developer here hard-coded the Artifactory API keys inside this configuration, and of course, when he pushed this configuration file to the remote public GitHub repository, this secret was leaked. Now, let's see how this token was generated, because that's an interesting part of the exploitation process. Here, my developer generated the key naively with a very simple use of the Artifactory user interface by simply clicking on the generate an identity token button. The thing is, when you generate a token that way, there are no options to define specific permissions. So, yep, no options. The developer just clicked through the window, and in the end, we can observe that the default permissions granted to the token that was just generated are unsafe. No one reads this, but if you have a closer look to the generated token, you can see that the scope of the token is the user. So basically, the token that has just been generated will inherit the permissions of the user. So everything the user can do, the token will be able to do, which can be bad, of course. Now, let's observe what happens on the attacker's side. Because if this token has permissions, there is a chance that the attacker can exploit it to achieve malicious purposes. So here, the attacker is already monitoring the developer GitHub repository and waiting for new commits to appear. Which is what is going to happen when the developer will push his configuration file to the remote repository. So here, the commit appears, and we observe that the configuration file has been found by the attacker, which is no surprise. The thing is, now the attacker can detect that there is something that looks like a authentication token in this file, and that this token looks like an Artifactory authentication token. So that's all the attacker needs to start interacting with the Artifactory server, and here it will start by downloading some packages, which it can do because the user was able to do it. Now that the package is downloaded, it can also modify it on its own machine, which is just local actions, so nothing special in terms of privileges. But now it can also push the package to the server, which is critical. If we summarize all this, what happened in this attack scenario? First, the developer pushed an API key to a public GitHub repository, which is what we call a leak, and we observe millions of times per year. But here, in that case, the attacker detected the leak on the repository because he was monitoring this repository, and he used this key, this leaked key, to download a software package from the Artifactory server. From here, he modified this package, injected malicious code in it, and he pushed a new version because the key he had access to had write access to the software repository. The new version gets published on the server containing the malicious code. Now the developer, if you remember, updated the dependencies of his project, and he observed a bump in version. And of course, the version he was using before was a sane version, while the new version is the one containing malicious code. And now, when the developer executes the application, he will also execute malicious code, which can achieve basically any malicious purpose you can think about: stealing local secrets, triggering a ransomware based attack, or something more convoluted. The thing is, in that case, only the developer was targeted. But if you think about it, the dependency on the server is compromised. So everyone that will try to use this dependency will also get compromised. This is the case for production server, third parties, CI/CDs, and other developers. That's what we call a supply chain attack. Now, what should we do when this kind of attack occurs? Well, first thing to do is always revoke the compromised secret. That's always fairly easy. It's no difference for Artifactory, which allows revoking a secret from the user interface as an administrator, for example, which can also be done from the API by listing existing tokens and then revoking a token based on its identifier. There's something more interesting because you can also revoke a secret based on its value, which makes the process easier, faster, but also with the usual side effects that if someone is using this secret, okay, basically a process might be broken. But that's the usual issues you might face. Once the secret is revoked, you want to investigate what happened during the time the token was leaked. And Artifactory provides a lot of logs, which include all the information you need to perform your investigation. Here, for example, we observed that a login was accepted for the owner of the compromised token. And most importantly, this login was performed from an unusual client IP address. So this is probably a malicious authentication. And just after this, you can see that a package was downloaded and a package was deployed, always from the same IP address, which means this package likely is compromised and needs to be cleaned. Okay, now let's think about what we can do to make this attack less effective or more difficult to achieve. To harden an Artifactory, we first need to have a look at how the authorization model works. The authorization model of Artifactory is based on what they call permissions, which targets objects like repositories or software artifacts, and will apply to users and groups. Each user, each group can be granted different access level inside the same permission. And also users can belong to groups. So users can receive their own permissions or privileges inside the permission and also inherit permissions from groups, which makes the whole model quite messy and it can become quite complex. To be able to easily and more effectively implement a least privileges policies, what we'd recommend in that case is to only rely on groups permissions and to avoid attributing rights to users directly. This makes the whole model less complex and will make the permissions more readable and more easily audited. Now, a very important thing is when my developer generated its own token, we saw that he had no choice in the scope of the token, which made the token inherit his own privileges. But that's not forced. You can do otherwise. And this can be done especially from the API. When you generate a token from the API, you can define very fine-grained scopes. For example, here, my user is generating a token that will only be able to read artifacts from the PyPile local repository. If it tries to use this token to push a package, that won't work. And also, this token will expire in an hour. So it's also possible to reduce the expiration time of a token, which is a good practice. And likewise, you can also generate a token that will only be able to push a package to the repository and won't be able to read or push any other package. That's pretty useful when you configure a token for a CI/CD pipeline that will have to push artifacts. There are a lot of other configuration options for tokens when you use the API to generate them, which we won't go into the details here. But what is interesting is that what we've just done, changing the way we apply permissions, changing the scope of the tokens, is just best practices in terms of secret management applied to Artifactory. Short-lived credentials is also a very good practice that we try to apply here to some extent. And those practices, good practice, shouldn't be limited to Artifactory, but that's something we should all try to implement in all parts of our information system, as long as our software allows us to do so. That's all for me. I hope you enjoyed this presentation and you learned new things about secrets and especially supply chain attacks. Don't hesitate to ask any question you have.